हे गाइस, अर्थम दिस साइड और आज हम सॉल्व करने वाले हैं CSES शीट का DP का क्वेश्चन नंबर 2 which is minimizing coins, right? So let's understand the question. So this question, what is given is, let's first read the question. So consider money system consisting of n coins. So there are n coins, right? There are n coins. Each coin has a positive integer value. Obviously, if it is a coin, obviously it would have a positive integer value. Your task is to produce a sum of money x. So it is also given in the question x, which you have to produce using available coins in such a way that the number of coins is minimal. For example, if you are given coins of 1, 5 and 7, and to clear your doubt, you have unlimited supply of all these three coins, so you can use multiple ones, multiple fives, multiple sevens as per your choice, right? What you have to do, you're also given a sum 11, which is x. That is sum 11 given. You have to use these coins and produce this sum, right? You have to use this coin and sum up those coins values to produce this sum, right? This sum. So and you have to do it in such a way that the total number of coins used by you is minimal, right? Is minimal. For example, one case would be you can use one's coins 11, which means you would be using 11 coins, right? Another way would be you can use two 5 coins, 5 plus 5, and one coin, which means you are using 3 coins, right? Another way would be you use one 7 coin and 4 1 coins, which means 5 coins, right? And they cannot be any other way. They can be multiple ways, right? So this would be the minimum way. This would be the minimum number of coins that you are using to produce this sum. So this is what you have to do. This is what you have to do. Yeah, I hope you have understood the question. Now let's first understand how the input is given. The input is given as this is the size of the array which represents the number of coins, and this is the sum you have to produce, right? This is the sum, and this is your array, which means you are given 1 coins, 5 coins, 7 coins, unlimited 7 coins, unlimited 1 coins, unlimited 5 coins, right? So let's first understand the approach, what's actually happening in this question, what actually we are required to do. So in this question you have to use multiple coins, so there would be any number of combinations of any number of coins. So because you can use a coin multiple times as per your choice, right? You can use 1, 5, 1 unlimited time, right? Any combination. So what you'll do, your approach would be to find out all combinations, to find out all combinations of coins, right? All combinations of coins that produces your sum, right? That produces your sum. And what you'll do, while you are preparing a particular combination, you'll keep on counting the coins you're using, number of coins you're using, right? For example, in 5 and 1, once you use 5, you will increase a counter 1, that you have considered a coin which is a value 5, and you have used a single coin, so counter of number of total coins would be, let's say this is coins, number total coin is 1, then you use 5 again, one more 5 coin, which means you have used another coin, so coin would increase by 1, then you have used a 1 coin, right? So count would increase by 1 also. So and these three are the only coins you have used, so total coins would be 3 only. So that's how we will approach this question. Let's build the algorithm and approach, right? What you'll do, as I have said, you have to find all the combination, and then you have to select the combination with minimum number of coins, in which we have used minimum number of coins, right? So let's say how will I do it. If you have seen my previous video, I have solved a similar question, right? I have solved a similar question of number of dice, right? First question of this CSESDP. What we'll do is we'll iterate a loop from 0 to this less than n, which will iterate through the element of this array, coins array, and I plus plus, right? And what I'll do is I'll say this coin would keep a count of all the coins I'm using. So let's say I have used this coin, first coin, which is on index 0. Then what I'll do is, which means if I've used this coin, if I've used this coin 1, then my sum would decrease, total sum. For example, if the sum is 11, right, and I have used a single one coin, the sum would become 10, right? Then if I've used 5 coin again, the sum would become 5, new sum. Then if I have used 5 again, the sum would become 0. And when the sum becomes 0, I can say that I have found a particular combination of coin, right? I have just found a particular combination of coin which is using 3 coins. and I don't know whether it's my answer or not, whether it's the minimal number of coins that can be used or not. But I have found a combination which would produce this sum, which would produce this sum. So I'm going backwards, right? I'm going backwards from the sum to 0, right? Deducting the coins value. Let's understand the approach now. What will happen? I will have to first increase a coin. Yes, I have considered a particular coin 1, right? I have considered a particular coin 1, and I will call the same function. I will call the same function f sum for further sum, for new sum. What would be the new sum? Sum minus this current value of coin which I have considered, which means ARR of I, right? Right? This would be our answer, which would find all the possible, now this logic would find all the possible combinations, right? This would find all the possible combinations of these coins which would produce sum 11, right? But what we have to do, in the question, we have to find the solution in which the number of coins we are using is minimal, right? The minimum coins which we can use to produce the sum, right? So how will we do that? I have also explained this in my previous video. What we'll do is we'll declare coin outside, and we'll say that your value isn't max, right? Your current value isn't max. Don't get updated until you find a smaller value, right? And what I'll do is I'll say that coins update, increase one in yourself, and call for further function, right? Call for further sum, right? Call for new sum. And new sum is sum minus ARR of I, right? ARR of I represents the value of the coin which you are on, right? Right? And what else you would do? You will also say that coins update 1 and call further, but only take this value if it is less than your current value. If it is not less than your current value, don't take it, right? Because we have to find the minimal value now. That's why we'll say only take this value into yourself if it is lesser than your current value. That's why we will have to take the minimum of both of these, 1 plus f and coins, right? We have to take both of these minimum both of these, right? So we'll say coin take minimum of both 1 plus f sum minus ARR of I and your value, your own value, right? If this new value 1 plus f of sum of minus ARR I is less than your current value, then update it, then update yourself. This means that, right? And what we'll do, we'll just simply find it and we'll return it, right? We'll return it. Now what could be the base case? If you found that sum is 0, right? Sum is 0, you don't have to do anything, you just simply return 0. Now your question would be, if the sum is 0, then it means we have found a combination which should return 1. No, we should not return 1. Why? We just have to count the coins, and we are counting it right here, right? We are counting it right here. We have to return some value when we want to actually calculate some value, right? Then we have to return value. If sum is 0, then we'll just return 0, right? And if sum is negative, what we'll do? Let's say your sum becomes negative through some combination. Let's say your sum was 11, which you have to produce, and you say that 7 and 7, you use 2 7 coins, which means 14, and 11 minus 14 would become what? Minus 3. Then your sum has become negative. What you'll do, that don't consider this combination. Coins don't consider this combination. And how coins would not consider this combination, this illogical combination which is not returning sum is equals to 0? You'll just have to, what you'll do, you say return int max. Whenever sum becomes negative, return int max. And if sum becomes negative, this value would return int max, right? This value would return int max, and 1 plus int max would be int max comma coins, and coins would obviously be less than int max, right? Would, if there are possible, if there is a way, then coins would be, if there is a single way, then coins value would get updated, and coins value would be less than this int max, right? Then what will happen? Coin would retain its original value and will not update this value on its own, for its own, right? So that's why we will return int max when sum becomes 0, so that coin do not updates its value and retains its value, older value, right? So let's quickly go through the code. In the code, what I have done is, this is my main function. I have just taken an input, first the number of the elements in the array, coins array, and the sum and for all those who do not know what is LL, let's look here. ll is nothing but long, right? So I have to reduce time, I have just used it as a macro, right? And I have taken array as input. I have called the function, here and passed array, number of elements in the array and sum, right? Then what I have done is I received all those three here, and I have just what I have done. I have declared a ll, long coin int max. What I've already told you why I have done this. Then what we'll do is we'll just iterate the array. We'll just iterate the whole array. Let's say your array was, what was your array? 157, right? 1, 5 and 7, right? Now what will happen is you'll call all the cases for one. You'll call all the cases for one for zeroth index, right? For zeroth index, then if you call this function for, what happen if you call this function for zeroth index, right? What will happen? Originally your sum was 11 in this case, right? Originally your sum was 11 in this case. Then for i0, you would access this value, you would access 1. Your sum would become what? Your sum would become, your this function would call 1 plus, now your new sum would become 11 minus 1, because you have already considered this coin. Then further you would call f of 1 plus new sum 10 minus 1, because you would again consider this coin, because every function call would go from zeroth index, right? Would access this array from zeroth index to last index n minus 1, which means you would call this function for all three, what? All three values 1, 5 and 7. Further you would call this function also for 1, 5, 7, right? So there would be multiple combinations, and you would return what? You would return the minimum value out of those, right? So let's look at the code, right? So what I had done is I had just explained this logic also. I just returned the minimum value of coins and 1 plus function for further sum, right? For further sum, new sum. This is the new sum which would be calculated by considering that coin, by deducting the value of that coin we are considering, right? And we'll just simply return the coin. But as this is recursive solution and we have not memoized it or tabularized it, it would give us giant huge time complexity. So let's understand quickly the time complexity of this solution, right? Then we'll go to memoization approach. So let's see, right? As this is a recursive approach, obviously the time complexity would be exponential, right? So let's how to find the time complexity of these cases. You just have to find how many times the recursive call is being made in a particular function call. Let's say for f11, 3 calls would be made, right? 3 calls would be made for 0th index, for 1 index, for 2 index, because the size of the array was 3 now. The size of the array was 3. For 3 so 3 calls would be made for f11 only, right? For 0th index, for 1 index and for 2 index, right? 3 calls are being made, which means if the size of the array is n, then n calls are being made, and a particular takes how much calls a particular take is, how much call is it making a particular call, right? Let's say f11, you take 0 and it becomes f10, you again take 0 and it becomes f9, and you keep on going until it becomes 0, which means a particular function call in worst case would make further function call. How many function calls? Some, right? In worst case some function call would be made for if the coin is 1, then 1 plus 1 plus 1 until some, right? Then total number of function calls, how many function call would be made? Total function call would be equal to sum, right? Whatever the value of sum is, that would be the worst case. That would be the worst case in which the total number of function calls are being made for a particular function call, right? So we can say that in worst case there would be some number of function calls, right? So time complexity would become what? Big O of n to the power sum, which is giant, which is huge, right? So we'll just do what? We'll memorize it. That's what we do. That's what DP is, right? Let's quickly go through how would we use memoization on this, right? So this is our DP approach. In DP we just have to, for declaring DP, what you have to do, you have to see how many variables are getting changed in one function call. You can see in one function call only one variable is changing, that is sum. So DP size would be only one dimension because only one variable is getting changed. So I have created a 1D DP, and I have made it of size sum plus 1. And you know, obviously, if you have watched any of my previous DP video, you would know that why we do this. For accessing some value, right? DP of some index would be accessed only when you have a DP of size sum plus 1. So that's the logic, right? That's the logic. We have initialized it with -1, and we have just passed it on the main function call, right? What and I've received it here, and I'll just change the code a little bit. I'll just check whether we have already calculated the value of sum, dp of sum. If dp of sum is -1, which means by which we have initialized it, which means we have not calculated the dp value, and we have to further calculate, right? We have to further calculate it. But if it is not equals to -1, which means it has some value, it has some value other than -1, which means we have already calculated the function call over this sum value, right? So we would say don't calculate it further, just return whatever the value you are storing, right? Just return whatever the value you are storing. And if that's not the case, then you have to calculate, you'll just calculate it and you'll store it, right? Before returning, you'll store it in dp of sum, right? And that's the logic, that's the whole logic, right? So this is the dp approach. Now let's go through time complexity, right? Now each function is making n functions call. That's clear, right? That's clear. N is the size of the array, n is the size of the array. So each function would make n functions call. And how many function call, how many further function call it would make? Up to some, but it would iterate every some value once, which means I can say that for n, for one particular iteration, for one particular index, I would go for the particular sum only once. Let's say the sum was total of sum values was sum, right? For one particular value I would go up to sum, right? Up to sum. For n particular values I would go, for n of these coins value I would go n into sum, right? So that would be my time complexity, right? So I can say that my time complexity would be n cross sum, right? Because every sum would be iterated once, and there are n iterations, right? So n times sum would be iterated, right? N times some number of values. So this is not exact constant, this is a variable, right? You can also say n cross m if you don't understand this way, right? So that would be a time complexity, somewhat n square, right? And our space complexity would be the size of this dp, right? Big O of n. So this was all for today, and this is our dp approach, and this is our recursion approach. And if you have not understood anything in this question, just drop down a comment, I'll reply as soon as possible. And that's all for today. We'll be uploading further Cses questions, right? And I'll be taking up other topics as well, like next could be string, right? Or any other topic. If you have a particular topic in mind which you would like to me to take first, I just drop down a comment, I'll do it. Okay, that's all for today. Code karte rahiye. All the very best.